Hey everyone, I am Kiran and from today we are starting our revision for the chemistry exams. As I already told you in this given series, we are revising the 10 most important chapter of chemistry in 10 classes. The first class is this one and we are starting our revision with the periodic table. We will first go with the some basic keywords which we will use in the chapter so often, and then we will go with the concept. Okay, so let's start with the periodic table. What is the meaning of that? See, there are many scientists who try to classify the elements and make their tables. We start with the Dobbe-Niner, the Newlands, and the first one who gave a very significant table which is very important for us, very successful at that time, was the Mendeleev. Now, why we call that as a periodic table, not just a simple table or the table of elements? See, the periodic word here, it's indicating something. What happened when we arrange the elements? After some time, you will see that they show periodically same properties. Because of that, we need to place these elements together, like because they have same property. That's why we call that table as the periodic table. Okay. So let's write that. So the periodic table comprise elements. See, I'm talking about the new one, the new periodic table. Elements on basis of their atomic number. Their atomic number, which shows same properties periodically. That's why we are using this word. Means after some time you will have the same properties. Now if you see this table, there will be two types of line. One lines are the horizontal line and the vertical lines, right? So the vertical lines we call them as the groups. The period we call them as the, like that. Just remember, groups are the vertical lines in the periodic table, while the periods are the horizontal lines. Okay. Now, because we have used them, let's start first with the role of Mendeleev. So, as I already told you a little bit about Mendeleev, so Mendeleev was the Mendeleev made a very significant contribution for the periodic table, right? He used this basic criteria of atomic mass and he arranged the elements on the increasing order of atomic mass and then make a periodic table. At that time around 64 elements are there, and then he made the periodic table for the around 48 to 49 elements. One of the basic significance in this periodic table is that after some time that Mendeleev used the properties as the main criteria, and he said that we should place the same elements if they have the same properties in the vertical column. Like if the sodium and the potassium have same properties, they should be on the same vertical line. And if, like, for that he sometime reverts the order of atomic mass also, it means that he make that more priority, right, the properties. And that was about the Mendeleev, one of the very famous scientists, and we call them as the father of the modern periodic table, right? But in reality we have now modern periodic table, and that is based on the atomic number. And the one who gave this first, that was the Moseley. Moseley was the one who gave this periodic table, or the principle of the periodic table is that the chemical and the physical properties are the periodic function of their atomic number, not the mass, and which later found out that that is the better, the atomic number. But because Mendeleev was the first one who made the official periodic table and used the atomic mass, that's why he had the very significant contribution, right? Now let's talk about the element representation. So how element look like, we are talking about that. If you see in the periodic table, to represent any elements, we should know these two things. One, we call it as Z. So the Z we call it as the atomic number. And then other one we have A. A is atomic mass. So to represent any element, we should be aware of these two things. Atomic number are, we can say, like the number of protons, which is generally equals to the number of electrons. See, and just remember about the number of electrons is that they kind of have only that the number of proton is equals to the number of electron only when the atom is neutral. means it should not have any kind of charge. And while the atomic mass is the equals to whatever inside the nucleus, that is the number of protons is and plus with the number of neutrons. So together they form this atomic mass. If we know about these two, we can easily represent any element. Then we should know the symbol also. Like for suppose nitrogen. So the symbol of nitrogen is this N. We will write the atomic number here at the here at the tail part, or here at the top we write down the atomic mass. So for nitrogen it look like that. So the 7 is the atomic number of nitrogen and 14 is the mass. So that's how we can represent any element. We should know three things: atomic number, atomic mass, and the representation or the symbol. So that's how an element look like. Okay, now let's move on. We have the groups of the periodic table. This is the whole periodic look like. You can see the vertical column. It start from 1 and it end with the 18. These are the total groups in the periodic table we have. Total 18 groups. Now see, some groups have characteristic feature, and because of that we have given the name for some of these groups, and we will discuss about that. So the first group which you need to remember is the group number 1, and we call them as the alkali metals. So obviously, as you can heard that they are metals, but they have alkali means the alkaline nature, basic nature, and basic plus they can easily soluble in water. In the same way, we have group number 2. Group number 2 we call it as the alkali earth metals. So they are also basic, but they have nature that they will be present. They are also alkaline, right? But they are present at the earth's surface. We have extracted them from the surface. That's why we call them as the alkali earth metal. Other than that, see, just remember that from this group number 3 and to this group number 12, these all elements from group number 3 to the 12, we call them as the transition metals. So that is the total metal or the in between metal we have. Then we have group number 13 to the 18. See, this group this is the one block we have actually. We have that have the metal, non-metal, and the semi-metal, all these three things. And just remember that some of the groups are very famous, like the group number 17, if you know, we call them as the halogen. And you can see this one I'm talking about 7. So the first member is fluorine, chlorine, bromine, and iodine. They all are we can call them as halogens. Then we have group number 18. This group number 18 is also known as 0, and in Roman numeral we write them like the third A, fourth A, fifth A, like that in the Roman numerals. This group is known as 0 because it have a 0 tendency to form bonds. It have a 0 valence or the 0 charge. But what you need to remember about them, that we call them as the noble gases. Noble means they don't react with other one is inert gases. These all are the name for these elements which is present in this given 18, like the helium, neon, argon, krypton, xenon. Okay, so this is all about the groups. We have 18 groups. You need to remember the first one, alkali metals, alkali earth metals. 3 to 12 we have transition metals. Then we have 13 to 18. These are all elements of the P block. If you don't know about P block, that is okay. You just need to remember the halogens and the noble gases. That's it. Group number 17 and group number 18. Let's move on to the periods. So periods are the horizontal lines, right? Like that. So we have total 7 periods in the periodic table. If you see the first period, we have only 2 elements. Second have 8, third have 8. Fourth and fifth have 18 and 18 element respectively. While the this period, that is group number 6 and the period number 6 and 7, they have 32 elements. If you count them, it's look like that they have the 14 like the fourth and the fifth, right? So actually the 14 element from this one and the 14 element from this one is actually we have placed them in at the bottom of the periodic table. Why? Because their properties don't match with the other elements. But even still they are in the bottom. That doesn't mean that they don't belong to this period number 6 and 7, right? Because of that, the 6 and 7 have 32 and 32 element each. And if you know the electronic configuration, that's how we write down, right? 2, 8, 8, 18, 18, 32, like that, because of these elements. We will discuss that later, but let's first discuss now metal and non-metal. Metal and non-metal. See, this metal and non-metal which we are talking about right now, if you see the whole periodic table, we have divided every elements as the metals, non-metals and the metalloids on the basis of some definition, right? Like the metal have a tendency to lose electron, are a good conductor, shiny, hard, and like that they have some strength like the tensile strength. These are the basic properties by which we define the elements, right? That how we call them as metals. So in the same way, just remember about the metals that they have a tendency to form cations, right? In the same way, the other property is that they are good conductors, right? Third one, we talk about they are hard and they are shiny. And the opposite of that, we call them as non-metal. They are like anions, are not good conductor. They can be hard sometime, but they don't have the color like the shiny appearance. In the opposite of that, non-metals, as I mentioned, so non-metal. So if you see the periodic table and we move from left to right, like in the periods, right? They are metallic in nature and their metallic property, metallic behavior decrease because in the starting we have cation, right? And cation are the tendency of metals. But later on they form anions, right? Opposite of that, it means that their tendency to lose electron decreases. That's why we say that metals, in the starting we have metals and then after some time they will be non-metals. So do we have any sharp border between the metal and non-metal? Yeah, so actually there are some element which are present in that border. They have both characters. They are not good conductor, they are not bad conductor, they are in between. So that's why they form semiconductor like the silicons, right? So we call them as this word as the metalloids. So the metalloids are those elements which have both behavior, both metallic and non-metallic, or you can say they are in between, non-metallic behavior, right? Mostly we will not say like the pure metal, they are pure metal, they are pure non-metal, but they are mixture of that, and that's why we call them as metalloids. There is one other name for them, we call them as the semi-metals. And one of the example, as I was telling you, like we have boron, right? We have silicon. They are form in the semiconductor also. Very famous semiconductor, the silicon, right? So we have around 8 elements in that borderline. So this is the whole periodic look like. As you can see here, the borderline start with this boron, silicon, right? And then we have germanium, arsenic, antimony, tellurium. Then we have this polonium and these elements. These two are radioactive, so we don't include that. So otherwise we have 1 2 3 4 5 6 7 8, as I told you. So these are the borderline we have, and borderline's left side is metal and borderline's right side is the non-metal. And this is the whole periodic table look like. Let's discuss few terms which is very important for us, like the alkali metals, that is the group number 1. Alkali earth metal, group number 2. Transition metals start from 3 to the 12. Then we have other metals and the non-metals remaining 1. Halogen we have the group number 17. Noble gases we have group number 18. Rare earth metals we are like the 21, 39, few elements, and from the lanthanide element also. Actinide elements are from this actinide series. Just remember, after this uranium we all have the radioactive element here in this case. This is uranium, right? Uranium is one of the element which use in the atomic bomb, and after that we have all radioactive elements. That's what periodic table is. Let's move on. We have now position of hydrogen in the periodic table. Now this is kind of very interesting, that we have very small element, the first element of the periodic table, and we want to know its position. Why we are not clear with its position, and why we are talking about that, why we are not talking about the other elements? So it means that there is a mystery behind the hydrogen, right? If you see the structure of hydrogen have one atomic number. It means that it have one electron, and to see that behavior, it have two elements or two groups where its behavior matches. One is the group number 1, that is the alkali metals, and next is the group number 17, and that is the halogens. So if you see how its behavior matches, like see, Na react with the Cl2 gas and form NaCl, right? In the same way, we have H2 react with the Cl2 to form HCl. That's how their behavior is. In the same way, if you see the group number 17 here, there are many halogen. I am using the chlorine for example. Chlorine react with the any metal like the Na, which we have just made it, right? It form NaCl, isn't it? In the same way, hydrogen also react with Na. Hydrogen also react with Na and form NaH. We can balance it. Now, how is that even possible? Actually, hydrogen have a tendency, it have one valency, right? One charge, and the one valency is for both the alkali metals and the alkali earth metals. Alkali metal have this tendency to lose that plus one charge. That's why while the group number 17 has valency as 1, that is minus 1, right? To gain one electron. But hydrogen can have the plus 1 and the minus 1 as well. That's why we are confused where we should position it. So let's discuss few elements directly, that is lithium, hydrogen and the fluorine, and we will see where we need to place hydrogen, lithium side or the fluorine side. Let's go one by one. So lithium, if you see at the room temperature, lithium found in the solid form, while hydrogen is H2 form, that is gas. In the same way, fluorine in F2 form, and that is also gas. So first point goes to the fluorine. Next one is about its valency, its electronic configuration. It is 2, 1. So there is one electron in the valence shell, we can say, right? While in case of hydrogen, there is just one. So it's kind of same, isn't it? While in case of fluorine, it is 2, 7. So fluorine have a different number of electron in the outermost shell compared to the hydrogen and the lithium, right? Okay, now let's move to the part 3. Here we will talk about the kind of compound they form. So lithium, because of this nature, see, lithium is because of tendency to lose electron, it have the metallic nature. While hydrogen is non-metal and fluorine is also non-metal. So this point is also goes towards the fluorine. Second point for the lithium. So right now 2, 1. Now next thing is that to have tendency to form cation. So lithium have a tendency to form Li plus because it will lose one electron. Fluorine have to accept in tendency to minus charge. So this is anion, we call it, and this is cation, right? The positive charge containing element is cation. While in case of hydrogen, it can be plus, H plus or H minus, both. Means it can gain electron, it can lose electron. Because of that, we are still confused. We are not sure. You will see some periodic table where the hydrogen is placed above the group 1 and sometime it is over the periodic table. But we don't place it with the group number 17 because most of the properties matches with the group number 1. So the 17 is not sure, not completely sure. That's why we can place it above the periodic table, okay? Let's move on. Now it's organization of the periodic table. We are organizing the periodic table. How it should look like. Now it's organization of periodic table. Now it's organization of periodic table. How periodic table look like? So we already know that we have placed elements on increasing order, right? And that behavior we call it as the periodicity, because after some time, because of having the same properties, they are repeating itself, right? They are present in the same groups. That is periodicity. Now we will have two types of trend here in the periodic table. One we see in the groups, like how their behavior is in groups, and the second we talk about in the periods, like how the elements behave when we are placing them in a same period. So normally what happen, if you see elements of the same group, you can use any group. For that I am using the group number 1. The first element of this group 1 is lithium, sodium and the potassium. So lithium have 2, 1 electronic configuration, sodium have 2, 8, 1 and the potassium is 2, 8, 8, 1, right? All these have a similarity that there is outermost shell electron is same, isn't it? So because of that we can say in case of group there is one tendency that will always remain constant, is that their outermost shell electron will always remain same. Because of that their chemical properties, see, because only this electron will participate in the chemical reaction, right? It will be always same for all these elements, right? While if we see a period, let's suppose we have this second period, it starts with the lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. I am not using noble gases because noble gases behave very differently than the other. So that's 2 1, that's 2 2, 2 3, 2 4, 2 5, 2 6 and 2 7. If you see, their shell number is still same, but the electron in the last shell or the outermost shell is increasing by 1, right? That is period for you. And because of that, because of these similar properties in a groups, in a period, you will see the properties are repeating itself, right? And that's, we call it as the periodicity. Okay. Now let's go one by one. First, let's discuss how the electronic arrangement change with the position. So I think I already told you, if elements are present in the same group, they will have same electron in their outermost shell, right? Only the shells are increasing. So like lithium, we have क्या दिमाग खराब है यार इनका. Like the lithium, right? Lithium have 2 1 as their electronic configuration. Sodium is 2 8 1. Potassium is 2 8 8 1. See, first similarity is that their valence shell electron is same. Second similarity is that they have increasing of one shell in each, right? First 2 shells, 3 shells, 4 shells and the 5 shells. So what you need to remember is that if they are from the same group, their chemical properties are same, their outermost electron are same, and one by one their shell number will increase. In the same way, if we see the elements of the same period, their period number is actually equals to the number of shells they have. Like the lithium have 2 shells, period number 2. Oxygen have 2 shells, 1 and 2, it have the period number 2. The chlorine have 3 shells, so the period number 3. That's how you can relate that. Now let's talk about how we can relate the charge and the group number. So we already know we have 18 groups, right? But there are 2 groups which is important for us, is the group number 1 and 2, 1 to 2, and group number 13 to 18. And for both we will use how we can calculate the ionic charge. Like first discuss them like directly, and then we will go a general formula. So first let's take the period number 3. We have the sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. And the charge on these elements, see, this charge is basically depend on how many electron they lose or gain. Losing is the positive charge, gaining is the negative charge. And it depend on the noble gases, right? Because they want to become like noble gases. So for sodium, it's 281. For magnesium, it's 282. For aluminium, 283. Silicon, 284. Phosphorus, 285. Sulfur, 286. And chlorine, 287. Based on this behavior, based on these electronic configuration, what we can say on the charge, that the sodium, magnesium, aluminium have tendency to lose electron, right? So they will have +1 charge, +2 charge and +3 charge. Silicon actually have a tendency in between. It do not gain or lose. It form covalent or sharing bonds, right? While the phosphorus, sulfur and chlorine will have -3, -2 and -1 charge according to that. So how we can calculate that? That is the first thing. How we will calculate that? Just remember, for group 1 and 2, you don't need to do anything. Whatever the number of group they belongs to, that will be their charge. If they are group 1, their charge is +1. If they are +2, their charge is also +2, right? But 13 to 18, we need to know how many electrons are present in their outermost shell. Then we can calculate. Like for 13, what we will do? We will subtract the group number with the 10, because 10's group are present from 3 to 12. That we need to subtract. So 13 to 10 is equals to 3. That is the electron present in their outermost shell. And then I think you can calculate, right? To be stable, what we need to do? We need to gain or the lose electron. So normally we lose electron, that's why it's +3. In the same way, if I have group number 17 and we want to calculate the charge on this, so what we will do? We will subtract with the 10, right? Same way. So now we will have 7 electron. To gain the stability, to gain the configuration like the noble gases, this 7 will gain 1 more electron. That's why the Cl have the negative charge. So we have these two formula. For group 1 and 2, it's direct. For group 13 to 18, we need to subtract with the this group number with the 10, and then we will get the outermost shell configuration. From that we can easily calculate, right? So this is the group number and the ionic charge. आई थिंक आई होप आपको क्लियर हुआ हो कि किस तरह से जब हम व्हेन वी गो फ्रॉम द पीरियोडिक टेबल फ्रॉम लाइक ग्रुप नंबर 1 to the 18, their electronic configuration will be like increase in a shell, but their charge will first increase and then decrease, right? That's how the charge work. Let's move on. We have the general trend in the periodic table, and the first one we have is the atomic radii. So see, atomic radii, we have so many definition for the atomic radii, and in reality these elements we are talking about, they don't found nature in they are always found in the joint form, right? Only except the noble gases, they are monoatomic. We have different way to calculate the atomic size, but because we are right now talking about trend, we need to see their behavior as we are moving left to down, right in the period, and up to down in a group. So let's start that atomic radii. What do you think about that? When we say atomic radii, what comes in your mind? So the atomic radii is the, actually we can just give a definition that the distance from the nucleus to the outermost shell, we call that as the radius. And what we need to see, how this radius or the distance will change as we are moving from left to right or up to down. Okay, so first we have period. I can use the period number 3. This is sodium, right? Then we have the magnesium. I can use with the 281, then 282, 283. That is the period, right? You can use example like first we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, like 284, 25, 285, 286 and 287. Now we are talking about atomic radii, right? Here there are so many factors we can use, but the best thing we need to use here is the how many charge they have. If you see sodium, just compare the sodium and magnesium, then you will know. Sodium is 17 electron and the 17 proton, right now, sorry, 11 electron and 11 proton, isn't it? Because that's its atomic number, and if it do not contain any charge, means the proton and the electrons are same. What do you think? Now what happen if we move from 11 to the 12? It have 12 electron and 12 proton. In the same way 13 electron, 13 proton. See, as the charge increase, attraction between them is increased, right? So attraction, if see this is atom and this is electron, if the attraction increase, the size will be like little bit shrink, right, from one atom to the, and that's what happened in the whole periodic table. So we can just say that in a period, atomic radii decrease. Okay, and what we can see why? Because in increase of nuclear charge. Okay, is it clear? In the same way we have groups. Now groups, if we use any, like I have used this first group as the lithium, sodium, potassium. I am using just 3 elements. What do you think? What behavior you will see here? Lithium is 2,1, it's 281 and it's 2881. That is the configuration I have written. So as you can see, as we are moving up to down, the shells are increasing, right, by 1. So obviously if shells are increasing, we don't need to consider the factor like the shielding effect and the all. So we can just write down that atomic radii increase on moving down, or left to right, or sorry, the up to down, you can say. What do you think about that? Okay, so the next we have is the atomic radii is done. Next we have the reactivity of elements, right? So see, reactivity depend on the element's behavior to gain or the lose electron. You know, the metal have a tendency, like if I use any metal like the sodium, it have a tendency to lose 1 electron and to form any positive. In the same way, if I will talk about Cl, it have a tendency to gain electron and form Cl negative. How quick they are, how quick they lose electron and gain the electron, it will define their reactivity. If you see for the metals, we have these 3 positive metals like Na plus, Mg plus 2 and Al plus 3, right? In the same way, silicon, in the middle one, the group number 14 have a tendency actually to share electrons. So we cannot compare it with the positive charge, and we cannot compare the positive charge with the negative charge, right? So together we can say, we have a question about these three, which one is more reactive. So for sodium, it's more easier to lose electron compared to the magnesium and the aluminium, right? They need to gain they need to lose 2 or 3 electrons. That is much. In the same way, if we talk about phosphorus, sulfur and chlorine, it have a tendency to gain 3 electrons, 2 electrons and 1 electrons. So the best is for the chlorine. Just remember, how easy they lose or gain electron will decide what is their reactivity. And this is what happened in a group. First it will decrease, then it will increase. That is the reactivity, okay? Now, if I will talk about groups, what will happen when the electron is coming towards the lower down, the up to down from a group? So we can use this example again. If we have the sodium, potassium and the lithium, so they all form +1 charge, but it's much easier for this potassium to have the +1 charge, right? Because it has a large size and easy electron will remove. So the reactivity will be highest for this potassium, isn't it? In the same way, if we are talking about the anions, the thing is negative. They are kind of gain electron. And the fluorine, chlorine, bromine and iodine, they have a different tendency. Out of them, fluorine is the most electronegative, will easily attract electron towards itself. So because of that, the reactivity will decrease in this case. Why? Because for iodine, it will react for sure, but it's not easy for iodine to gain electron or anything like the other one. So just remember that here the reactivity will decrease when we are in a period, when we are in a group. So we have 2 types of group, one reactivity increase, one reactivity decrease, okay? Move on is the density and the melting point. See, density is about the mass by volume, and to check that we need to compare their mass and volume. So when element size is shrinking, in a period, you can easily say their mass is increasing but their volume isn't, right? So the density is increasing. In the same way, if we are talking about period, then the volume and mass both are increasing. It depends on us which we need to use the more priority, because it actually not just us, means we can define that density. Like if I am using this group, the lithium, sodium and potassium, their density will increase if their mass is increasing compared to the volume. But in reality, mass is increasing, that's correct, but their size is increasing a bit more, right? So because of that, we say their density decreases. So you can just remember that if we are going in a group, their density will be decreased, right? And if we are going in like the period, lithium, beryllium, boron, carbon, their density will increase. That's how we need to remember, okay? Next thing we have about melting point. Actually, melting point and boiling point have a very exceptional behavior in the periodic table. In a group, the same way as reactivity, here we also have 2 tendency, one for the cation, one for the anion. For cation, just remember that I'm talking about melting point, okay? So what you need to remember that for melting point, that if elements are present in a group of cation, their melting and boiling point will be decreased. While they are present in the group or cation where we are moving from left to right, that is a period, their melting point will behave differently. It first start from, like suppose I am using this group period number 3, the sodium, we have magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. First it increase from the sodium to the silicon. Why? Because these are metals. See, when we are saying melting point, we are if we have the solid state of these elements, we are separating them, right? We are separating 2 Na molecule, 2 Mg molecules or whatever we have. To separate them, between them there is a working of the metallic bond, right? They have metallic bond, very strong bond. So because of that, their tendency to like separate them, it's not easy, right? In the same way, if we talk about these 3, it's like phosphorus, sulfur and chlorine, all are the non-metals, right? And we talk about them, they have the other factor, they have like how much charge they have. See, charge is related to the polarity, right? And higher the charge, higher will be, we need to use more temperature to remove them. isn't it? Because their intermolecular interaction will be high. So because of that, it will be highest for the phosphorus and easy for the chlorine. I'm just comparing them. I'm not saying for chlorine it's easy. I'm just asking, like I'm just saying that because it fluorine, this phosphorus have -3 charge, chlorine have -1 charge. So for we to separate, it's easy for chlorine and difficult for the phosphorus. Okay. So this is it. We will go trend again with the groups, different groups and the periods, but that's how work. We have discussed three things. One is the reactivity, atomic size, and this density and melting point. So this is the diagram. As you can see how density and the melting point change in a period. The density is this one, the first one, the green line, as you can see, while the melting point and the boiling point graph is the red or the blue one. In the boiling point and the melting point, you will see the group number 14 have a highest value because it have a tendency not to form the cation or the anion. So the intermolecular interaction will be higher for that because of its structure. These Na, Mg and Al, as I already told you, they have the positive charge. They are actually metal. So they form the lattice structure. Metals are always present in the different lattice structures, the crystal type structures. So it's very difficult to separate them. Higher the charge, higher will be the difficulty. That's why melting point first increase, and it is in highest for the silicon, right? This is the one which is which shows the covalent bonding. Other than that, if you see the structure of silicon with the silicon together, they have a very GANT structure, GANT molecular structure. Many silicon will be arranged and they are forming this macro structure, and it's not easy to separate them. Then after that, when the negative charge is there, negative is having the only polar interaction, so it's much easier to separate them. So we need less amount of temperature. So this is the melting point and boiling point, and now this is the whole periodic table we have. We already know about the sum of the properties. We don't need to go with the electronegativity and affinity still now. In the same way here, we need to see how element size is decreasing, right? When we move from left to right in a period, the size of atom is decreased, right? Their metallic property decreases, right? Metallic property is because this side are the metals, right, and this sides are the non-metals, so their metallic property also increase here in this case and decrease here this side. So if you're talking about in a period, metallic property decreases and up to down metallic property increases. That's what we need to remember in the trends. Let's move to the each and specific group. The first one, we have the alkali metals. Alkali metals have some elements. We need to discuss only these three: lithium, sodium and potassium. They all have one valency, as you can see, right? Their outermost shell electron have one electron. So that's what we need to remember about them, that there is only one electron here. About their physical properties, so they are metals, right, and they are very soft metals, soft and shiny metals. So they can easily cut by any pointed material. That is the first one about them. They are good conductor because they are metal. They have a tendency to form the cations, right? Other than that, all elements have some specific color when they burn down, right? About the potassium and sodium, we need to remember one thing is they are very reactive. They are very reactive, and when they react, they kind of the exothermic reaction they shows. Because of them, it's very difficult to store them. So to store, for the storage purpose, what we can do, we can dip them in the kerosene oil so that they will not react further with any other one. So this is the physical properties we need to remember about the these alkali metals. Some physical properties we can see here also, like how we can define their physicality. So we already know they are metals. They're hard in appearance. One more thing is we need to remember about their melting point and boiling point. So we already know when we go up to down, right? For the metals, for the cations, their melting point is decrease. Just remember, for these metals, they when we are moving from this lithium, sodium, potassium, their melting point and the boiling point will decrease. Why that? So it's because the metallic bond is stronger when the size is smaller, and as the size of the atoms is increased, their melting point or their tendency or their intermolecular interaction will decrease, so it's easy to separate them. Now let's talk about the properties and what happened here. We have these different metals like these three which we need to discuss: lithium, sodium, and we have the potassium. When we are trying to use a reaction, that when we react with the acid, what kind of reaction we see. So lithium react with the acid like the HCl to form LiCl, right? And the other gas we will have is H2. So to balance that, we are using 2 here. That is the reaction we have. This reaction right now we are talking about. So the gas will be evolved in all these cases. This reaction will be for the all of the chemical we have right now, but their tendency and their way of reacting will be different. Like for the lithium, we have lithium Cl will be formed, but the gas which will be evolved, that hydrogen. So it's a kind of bubble like sound we will have, right? In the same way for sodium, the same thing will happen. But what do you think? Reactivity will increase or decrease as we are moving from this lithium to the sodium? Because sodium have larger size, larger atomic size, its reactivity will increase, right? That's what we are talking about. So because we know the atomic size increase, so reactivity will increase. So there will be H2 evolve for sure, but there will be more bubbles, right? In both cases, bubbles are there here, but there is less bubble. Here it will be more bubble, and here it will be much more bubble sound. So it means that the hydrogen production will be higher in case of H2, right? And the reason is, as I already told you, it's because they are more reactive. Their size is higher, so it's very easy to react them. Heat, these all reaction are exothermic. But if we talk about that, potassium will be the highest one. So it will be evolving heat, but very less amount. It will also evolve, but it will be more production of heat will be there. And here it's very much more, that much more that we need to use very like different things for that. So we cannot use our bare hands, and we cannot with the naked eyes. We need to use some glass over it. So that's why here will be much more heat, right? Formation of alkaline solution. Now what are they talking about? They're talking about the what happened after the reaction. See, if I will use this reaction, that's Li. Here we are talking about all the reaction the lithium can have. So lithium react with the H2O and will form the LiOH, right? With that, there will be hydrogen gas evolved. I'm not balancing this reaction, but that's how product is look like. So you can see LiOH is producing, right, in this chemical properties. So for this one, we have hydrogen gas, but this one is the salt. If the reaction is this one, if we are talking about that, then there will be alkaline formation, right? And if solution is alkaline, the color will change. So the color is changed to the purple. But for the first case, in case of lithium, the purple is not very sharp and will take time. Here it is a sharp purple, and here also the sharp purple. It means that we can be define the reactivity on this basis, isn't it? Flame, in first case there is no flame for the lithium. For the sodium and potassium there will be flame, and the potassium will be, it can even ignite the hydrogen gas. That kind of intensity we can see for this one. So this is alkali metal, the first group we have. Other than that, we need to compare the group number 17 also, the halogens. We have fluorine, chlorine, bromine, and iodine in this group. All have similarity. Their valence shell electrons are same for all of them. It's 2, 8, 18, 7, and for iodine it's 2, 8, 18, 18, 7, right? Their physical properties are that they're almost present at the gases except the iodine. Iodine is the one which is present at the solid form, right? And there is bromine which is kind of form in the liquid, but the fluorine and chlorine are present in the gaseous. The fluorine and chlorine, out of them all, the fluorine and the chlorine are the most reactive and easily react and form this different type of structure according to the properties. Their melting and boiling point is actually increased down the group. As you remember, in case of alkali metals it was decreasing, right? Here it's increase. So that's point you need to remember to compare. Now if we talk about the chemical properties, these halogen can show different property. They can react with the other different elements, like they can react with the H2, and I am showing halogen by X2. So they form this compound like HCl, right? And this is hydrochloric acid. If I am using here X in place of X, I am using Cl2. We can form other acid also. Because of this behavior, they can show the displacement reaction. What is the displacement reaction? That they can displace a group because of their higher reactivity. The chlorine can also react with the water and can form the acid, not just HCl but HClO also. This is hypochlorous acid. Hypochlorous acid. See, this hypochlorous acid is act as the oxidizing agent, means it provide oxygen for the oxidation, because this oxygen can be easily removed out, right? And that's why it kind of behaving like the oxidizing agent. And this is the behavior. There are two acid here. This is hydrochloric acid. Hypochlorous acid means when the chlorine react with water, it form two types of acid. Other than that, what reaction we need to remember about them, that they can I already told you about the displacement reaction. What happened? We have 4 halogen, right, in the halogen table. Fluorine, chlorine, bromine and iodine. If you see the reactivity between these three, because for fluorine the structure is very complicated and very unstable, so Cl will have higher reactivity than Br and then I. So when we react Cl2 with HBr, it can replace this Br and sided, and it will form HCl then. So that kind of reaction that we call displacement, because Br is Cl is displacing this Br and in that place forming bond with H. So these are the reaction we can see for the halogen also. That's displacement reaction. We have given here this table which we need to see. See, this is very important table because many reaction we cannot use one by one. So let's just see. First, they are halogens and they can easily have a color, because their tendency to gain electron, right? All structure is not, it's not the complete or the fulfilled structure. So because of that, there will be a change of color or there is a bleaching going on. Then if they react with the iron wool, so iron wool is like iron. So when they react with the iron, like the Cl2, they will form this FeCl3 type structure. Here the iron is having the +3 oxidation state. And this is the for all these reaction that, and out of them which one will be reactive faster? Obviously the chlorine, right, which is most reactive. Okay, and then if we need to react chlorine with the chloride, that will not happen because both are same, right? But it can react with the bromine. But see, the reaction condition is that more reactive will be react with the less reactive. Since chlorine is the more reactive, we have Cl negative, but bromine doesn't have anything to give right now. So that's why they have written no reaction. In the same way, if chlorine react with the bromide, the reaction will happen, isn't it? Because the chlorine is more reactive. So it will displace this bromine from here and add a bond with this K. Here, no reaction, no reaction. In the same way, for iodide, we can have the chlorine displacement reaction. We can have the bromine displacement reaction. And that is the reaction for the halogen. So I hope aapko clear ho. I hope this is clear for you. Let's move on. Then we have the noble gases. So the noble gases, all gases, we have the lithium, the neon and the argon, the xenon and the krypton. There is one more, but that is the radioactive, so we don't need to consider it. We just need to remember about them. So they have, if you see their electronic configuration, that is the most idealistic configuration we can have, because their outermost shell is fulfilled, right? Because of that, they don't form bond normally with the other elements, and they can use for the different purpose. Like for the helium, we use them in I just don't remember. Yeah, the balloon we use, right, for the skydiving or something. Not skydiving, we go up with that balloon. Neon is very famous for its color. It shows it have very sharp appearance that we can see in the night also, the neon light. Argon is also used, xenon, krypton, they all have their individual uses, but one we need to consider is that we call them as a zero group. Why we call them as a zero group? If you check, they don't take electron, means they don't give electron and the lose electron, right? Because of that, their valency, this term we call it as zero. No gain of electron, right? And no lose of electron. Because of that, they have this tendency like to not gain electron or not to lose electron, because they are already filled. So we call them as a zero group because of this name. So yeah, that's it about that. We don't need to do that much more. If we see in a period, we already discussed about that how the radii work, right? Radii, like, let me give you one by one a quick view. If we see about the atomic radii, we will say it's decrease, right? It's double I, sorry, decrease. If we talk about the metallic character, it is also decreased, right? Because starting the metals, then they become non-metals, so obviously metallic character decreasing. Third, we have reactivity. So the reactivity, as I already told you, we don't have any specific way, but first the reactivity is decrease and then it's increased, right? Because Cl and the Na are the most reactive elements of that period number 3. Fourth, we have, which we need to discuss, is the melting and the density. So melting and density don't have like very specific behavior, but just need to remember that it's like a mountain. First it increase and then it's decrease. So this is the general trend for the period. So next we have transition metals. So we already have talked about that the elements from like group number 3 to the group number 12, we call them as the TM, the transition metals, right? So why we use this word transition? Because we are moving from metal to non-metal. So their behavior is not exactly like the group number 1 and 2, kind of different, but they are metals, means they have a tendency to lose electron, having the conductor behavior, other things, right? So transition metal we are discussing at the end because they don't shows this behavior like the periodicity with the other element, other groups like the 1 and 2 or the 13 to the 18. They are separated, but they are metallic in nature, right? So let's discuss some general properties of these transition metals, like if they are metals. So first is that they are hard. They are hard and some are the shiny also. So that is the first character. Other than that, they have very high density. So high density is because of their smaller size also. The size is small but their mass is high, means volume is smaller and the mass is high, right? So that's why their high density is very high. Third, about which we need to remember, is their melting point. So they have very high melting point and the boiling point, right? So that is the general properties of the transition metal. Now let's discuss their unique properties, which doesn't match with the other metals. So the first one in this properties we have that they are colored. So every transition metal have different color. So these TMs are colored elements. That is the first property we have. Second we have is that they are catalyst. They act as catalyst in many reaction. That is the second. Third is that see, because of its behavior of like, see, all are generally related, means it doesn't mean that if there is one property the other how that. So these all are interconnected, and the main thing is that these transition metal have so many empty and the half empty orbital. They can extend the number of electrons. That's why it happens. So the third property is basically based on that they can have multiple oxidation number, right? Multiple oxidation number. And these multiple oxidation number, I'm talking about charge. Like for example, you have seen iron S plus 2 and iron S plus 3, right? Both are the charges of carbon, the iron. So it's plus 2 and plus 3 also. The fourth and the most important thing is that because of this charge, they can have the different type of structure also. Like they can have many oxide and the hydroxide. Or you can say like the halides. You can use any metals you want, but that's it about these transition metals, that they are colored, they form catalyst, they have the different oxidation number, and also that they form different type of structure. It's not oxide only, like for Fe we can have these two oxide based on this formula Fe plus 2, one for the plus 2, one for the plus 3, right? About the halide, same, like FeCl2 and FeCl3 both are there. So these are the transition metal, and with that our chapter finish here. So if you want to solve some question with me, we can have a class for that. Please write in the comments for that. So we'll see you in the next class.